Today we're going to look at electric charge and current. So charge is this thing here, Q, and current is this thing here, I, and this thing here is just the time, T, in seconds. So the unit for charge is a coulomb, and the unit for current is an amp, and the unit for time is a second. And the definition for current is the rate of flow of charge. And that sort of makes sense because using this equation here, if I wanted to just get what current means, I would divide both sides by time. So if I divide this side by time, I've just got current by itself. If I divide this by time, I just have Q divided by T. Now going back to the definition, the rate of flow of charge. Now the rate of something is how long it takes. So we'll find out how long Q takes to flow, so how long the charge flows, by dividing it by the time, and that's essentially what the definition for current is, and that's how this equation can help us remember the definition for it. Okay, hopefully that makes sense. And then over here we have a circuit, and this is to show that these are the ingredients that make up an electric circuit. You have a source, you have some wires, the conduction path to let the electricity flow, then you have the load, something that uses up the energy. So the source over here we have a battery. Remember, a battery is just loads of cells added together, and that's the symbol for a battery. And our conduction path is the wires, so what leads the battery to the load. And over here the load is resistors, because remember that's the symbol for a resistor in a circuit. So that is a typical electric circuit, and you'll note one other thing about this circuit is that the resistors are in series. So let's have a recap of Ohm's law. It's kind of an important one because it relates voltage, current and resistance all together. And I've done a little example here on how you can think about it a different way. So if these little red dots represent the current and this blue line represents the resistance, if you've got a really small blue line, a lot of your red dots are going to get passed. But if you've got a really big blue line, not many red dots are going to pass. So what that means that if your voltage pretty much stays the same, so if this stays the same, for an increase in your current, you're going to need a decrease in your resistance. So here we've got a lot of current flowing, but we've got a really small resistance. Whereas here we've got a really big resistance, which means not many red dots can pass, so your current is reduced. So that's another way to think about Ohm's law if you don't like thinking about equations. Hopefully it makes sense. And yeah, thanks for watching it. Bye guys.